Welcome to Algebra 1, Chapter 5, Section 7, Scatter plots and trend lines. Is a graph that relates two different sets of data by displaying them as ordered pairs. We use scatter plots to find trends in data. This shows a positive correlation. When x increases, y also increases. So you get a positive trend or a positive correlation. In this example, we have a negative correlation. The slope is negative of our trend line. As x increases, the value of y decreases. In this example, the two sets of data are not related. There is no correlation. There is no trend line, so you do not have a positive correlation nor a negative correlation. A scatter plot is simply a graph that relates two sets of data. In this case, we're going to plot each ordered pair to make a scatter plot. So I go 2, 3, and put a dot. -1, -2, 0, 2, -2, 0. Now, as you can see, this is not a line, it's not an equation. But as our x value increases, our y value also increases. So our trend line would be in that area. Is correlation? A correlation is a measure of the strength of a relationship between two quantities. This scatter plot has a positive correlation. This scatter plot has a negative slope, negative correlation. This scatter plot for number 7 has no correlation. Pause this video and use this table to make a scatter plot. Note that the label on the bottom is dollars spent, so that's your x value, and your y value is going to be the gallons bought. So how'd you do? Now, using the scatter plot, underline the correct word or words to complete each sentence. The number of gallons bought tends to blank as the number of dollars spent blank. The number of gallons bought tend to increase as the number of dollars spent increases. And because of that, you will see that you have a line that goes up, which means it has a positive slope, which means it has a positive correlation. Take a look at this example. We have a population of a city and the number of letters in the name of the city. Would you expect a positive correlation, a negative correlation, or no correlation? Explain your reasoning. Well, think of Leslie. How many letters are in the name of our city? L-E-S-L-I-E. So we have 6 letters. Approximately how many people live here? Well, I would guess it's probably in the thousands at least, a couple thousand. Is there a correlation between that? So think of another city. Let's think of Detroit. There's lots of people that live in Detroit. D-E-T-R-O-I-T. There's lots and lots of people. So that has to be in the 10,000s. Is the size of either city dependent on the number of letters in its name? Of course not. That would be silly. So in this case, there's no correlation. It has no relationship to each other at all. A trend line is a line on a scatter plot. It's drawn near the points that shows a correlation. There should be about the same number of points above the line as below it. Line of best fit. Well, a line of best fit is a trend line that has about the same number of points above the line as below the line. Usually there's no single line that passes through all of the data. But we can use this line of best fit, this trend line, to describe the trend of the data. The reason we have a line of best fit or a trend line is to make predictions. Using this, we can predict the values within a data set or outside of a data set. Linear interpolation. This is the method of estimating the coordinates of a point that lies between two given data points. Linear extrapolation is the method of estimating all the coordinates of a point that lies to the right or the left of the given data points. Causation versus correlation. Causation is when a change in one quantity causes a change in the second quantity. A correlation between quantities does not always imply causation. There can be a correlation without a causation, but if there's a causation, there definitely is a correlation. In situations, is there likely to be a correlation? If so, does the correlation reflect a causal relationship? The number of loaves of bread baked and the amount of flour used. Yes, there should be a correlation. And yes, it should be causal. The number of mailboxes and the number of firefighters in the city. There could be a correlation. So yes, for the correlation. Because, the more people in the city, the more fires there could be, which means there's a higher need for firefighters. But did having more mailboxes cause there to be more firefighters? In itself, no. So in this case, it's not causal. This problem and those that follow, we will discuss in class. Make sure you bring this packet with you, and I'll see you in class tomorrow.